Alright, here is my video guide for lesson 5.1.4 and how we can apply these trig ratios, whether it is our standard trig ratios, sine, cosine, and tangent, or our inverse trig ratios, sine inverse, cosine inverse, or tangent inverse. We're going to look at problems today which incorporate both of them. Okay, now very short lesson here, only 3 questions, but they are more difficult questions, and so this video guide is meant to be exactly that, a guide through these problems. And this one I'm actually going to be giving you quite a bit because I know the difficulty, I know the level of difficulty these problems have, and so I want to make this as a learning tool for you and help you through these problems. Okay, remember, as I'm doing these problems, if anything seems weird, anything seems off, or if you have further questions, always reach out and email me, and I will be happy to explain things further. So this first word problem, is that we have David and Emily, and they're climbing El Capitan, a big cliff wall in Yosemite National Park. If you've never seen El Capitan, look it up. Pretty cool thing, actually. So David is on the ground, and he's holding a rope attached to a carabiner, a rope pulley that is on the wall above Emily as she climbs. Emily stops to rest, and David wonders, how high has she climbed? The rope is attached to his waist about 3 feet off the ground, and he has let out about 48 feet of rope, which goes up to the carabiner and then back down to Emily's harness. The rope at David's waist makes about a 55-degree angle with the ground, and he is standing about 20 feet away from the base of the wall. And so I'm going to help you here draw out what this problem looks like. And so you have you have El Capitan over here. You have this carabiner that's on the wall, so it's creating this loop where the rope is going to go through. And then you have Emily somewhere on the wall. Okay. Then you have David on the ground. He's got a big head. Okay. And he has this rope going from his waist up to the carabiner, and then it loops back down the carabiner and goes and connects to Emily's harness. Okay, he's also standing, it says, let's see, he let out 40 feet of rope. He's standing 20 feet away from the base of the wall, so we know this distance to the base of the wall. We also know that the rope is, or his waist is 3 feet off the ground. So we know this distance right here is 3 feet off the ground. We also know that the angle in here is creating a 55-degree angle. And what did I say? That we were standing 20 feet away from the wall. So that's 20 feet away, a 55-degree angle, and that the harness itself, or the waist rope on his waist, is about 3 feet off the ground. Any other piece of information I'm missing in here, that he has 48 feet of rope, but we're not going to use that quite yet, but it will come up. Okay, the first thing I'm going to do is, assuming that this rope is taut between his waist and the carabiner, how long is that rope from his waist up to that carabiner above Emily's head? Well, I can set this up. This would be like my X here. I can set this up with trigonometry, a trigonomic function. Okay, I notice that I have my adjacent here, because my 90 would be right here. And so I have my adjacent, and I have my hypotenuse. Adjacent hypotenuse tells me this is a cosine problem. And I can do the cosine of my angle, which is 55. Set that equal to adjacent divided by hypotenuse, which is 20 divided by x. And I can put this over 1 and start to solve here. 1 times 20 gives me 20. The cosine of 55 times x gives me the cosine of 55 times x. Dividing both sides by the cosine of 55. And I want to make sure I use this on my calculator to do it right. I got 20 divided by the cosine of 55, and I got 34.87. 34.87. So x equals, like I said, 34.87. Oh, what I'm going to do, I'm actually going to use this 48 feet of rope, because I know that out of that 48 feet of rope, 34.87 of it is used from his waist to the carabiner, which means the remainder of the rope is from the carabiner down to Emily's waist. So I'm actually going to take 48. I'm going to take this 48 and subtract it by 34.87. So 48 minus 34.87. And I know that there is 13.13 feet of rope between the carabiner and Emily's harness there. Okay? That's going to come and play an effect in this second one. So it's asking us now, how high has Emily climbed up the wall? Okay? So what I'm going to do is I'm going to find this total height of the triangle, or total height from the bottom bar here all the way to the carabiner, and then I'm going to subtract out the 13.13 that she's hanging down from the carabiner. Okay, so to do that, to first find the total height, I'm going to do the tangent, okay, because this is opposite, this is adjacent. I'm going to do the tangent of 55. Set that equal to my opposite, which is x now. I'm missing that, so that's x over 20. And I got to put this over 1. Now again, using my calculator here, I should get that x equals whatever the tangent of 55 times 20 is, which is going to give me 28.56. Okay, now a couple things I need to do here still. I need to add the 3 feet from his waist to the ground. So this actually becomes adding 3 feet. Gives me 31.56 feet. Right, and so that is the total distance from the ground to the carabiner. So now I need to subtract out the 13.13 that she's hanging down from that carabiner. So I'm taking this total height of 31.56, subtracting out that 13.13 she's hanging down, and I'm left that she is, and let me put it in my calculator so I get the exact number, 31.56 minus 13.13, and I got that she is 18.43 feet above the ground. So that one I worked completely out because I know the difficulty of that problem. Let's take a look at the next one. So here, this one's a little more straightforward. We have a 70-foot tall pole that's holding up a tent. So we have this 70-foot tall pole, it's holding up a tent, and there is a wire, a support cable that's going from the top of the pole all the way to the ground. And where it meets the ground, it forms a 60-degree angle. Okay, so we know this is 70, we know that angle there is 60. We're looking for how long is the cable, so I can call that x. And we can set up a trigonomic ratio, a trigonomic function to solve for x. And then it's also going to look like in part B is how far from the ground should the cable be attached. And so you're looking for maybe y down here, this distance down here on the bottom. Okay, and so you can set that one up and solve a little more straightforward without all the moving pieces. Now this one here is difficult, but again, I'm going to kind of give you the tools to this one, and I'm going to see how you can handle it. There's an e-tool that helps you see it, and I like to draw this one out by hand again. So again, we're talking about them climbing El Capitan, and we're going to look at different places on the mountain that they are at different times. And so we have, again, El Capitan over here. We have Emily climbing it over here. And I'm just going to set up one diagram. We have Nathan looking on, and he's looking up at her, and we have this triangle forming from his line of sight here. And I think the last piece of information is that his eyes are 6 feet above the ground, so we know that from his eyes to the ground here is 6 feet. At first, he's looking up at a 10-degree angle. Okay, and we're trying to figure out how far he's standing 185 feet away. So we need to solve for how high up she is. Okay, what we're going to do, and we've done these problems before, is we're going to do the tangent because we're looking for x, our height over here. So we have the tangent of our angle, which is 10 degrees. We're setting that equal to the rise over the run, which is x over 185, or what I should say is the opposite over the adjacent. And you're going to solve for x here. Don't forget when you have an answer for x that you need to add in the 6 feet from his height at the end. Now the problem changes in part B. She climbs a little bit higher by 1130, and the only thing that really changes for us is that instead of 10 degrees, he's looking up at 25 degrees. And we want to talk about the distance she climbed in the last 30 minutes. So you're going to have a total distance here in part A. X equals your total distance here in part A. And you're going to find your total distance in part B that she climbed. And you're going to take your part B distance, subtract your part A distance to see how much did she climb in that 30-minute time period. Okay? If you're kind of confused by that, again, reach out and ask me on that one. I can kind of show you a little bit more what I mean. Okay? Then what you're going to do is you want that total distance you got in part B. Okay? How high did she climb, or how high is she at the end of part B? Then you're going to add 32 feet to that in part C. And what you're going to have is some distance x that she is off the ground, and then you can do an inverse trigonometry problem to figure out your angle. Okay? You're going to have an inverse trig problem to figure out your angle. So I'm leaving these ones more blank to see, can you handle a problem that is difficult like we see here in B and C. Again, if you're struggling, make sure you reach out today. I'm available all day to meet and talk about some of these, or a couple of these problems, because there isn't very many of them. Hopefully this video is helpful. Hopefully it showed you some things and helped solidify some of these concepts like the inverse trigonometry and the regular trigonometry.